All right. Hello, everyone. So, sorry for the late start. Just had some small issues here with OBS not finding my microphone anymore. So figured that folks probably wanted some sound in this live stream. So I fixed that now, and things should be behaving. Um, yeah, so effectively back to live streaming. I got back from 2 weeks spent in Europe with the first weeks kind of split between meeting a bunch of the Future Fusion employees. We had like a bit of a company gathering, working on a few things, which kind of culminated into us releasing the migration manager code base publicly. So we have it now here on GitHub. It's still kind of work in progress for the basics. Like the code is there, but there's still a few components missing, especially around what we use as the worker process to effectively do the data transfer and stuff. It's a bit tricky because of VMware SDK components and some libraries and things. So we're still working on how to best handle that so that we can ship as much as we can as just the open source Apache 2 code base, and then you just need to slot in a tiny bit of like that part of the SDK coming directly from VMware effectively. So anyway, we're working on that, trying to make it all behave pretty quick. It's got a web UI, it's got all that kind of stuff in place. Documentation is another aspect that we're still working on to get like clear getting started and all that kind of stuff. I'm looking at recording a video of how Migration Manager works and showing it working with a bunch of VMs moving from VMware to Incus. So I'm gonna have that up pretty soon. All right, so that's kind of what I've been up to for the first part of the week. Then was followed by FOSDEM. So we actually had a Friends of Incus gathering on Friday evening. So I got to meet a bunch of Incus users and contributors. That was really good. I think total group size were like 28 or so at that thing. So that's really good for our first kind of in-person gathering like that. So it was really nice. And then Saturday, Sunday was FOSDEM. So Saturday was focused on containers. So I ran the container track for the whole day. We had 2 talks on Incus, a bunch of talks on various aspects of Kubernetes and other type of containers on other operating systems, quite a lot of content. Most of those, all of those were recorded. Most of those are already published now. I still need to finish reviewing and releasing, I think, a couple of them at this point, but we're mostly done going through the video recordings for FOSDEM. Then Sunday was the kernel dev room, so kind of same thing as Saturday, ran the thing the whole day, but this time was focused on kernel development. A bunch of different topics, anything from like Rust on Linux, a bunch of scheduling stuff, memory management, quite a few topics kind of all over the place. Also things like CI and automatic like code update and that kind of stuff. So a lot of really good topics. Was good to catch up with a lot of people. It was quite the busy, exhausting week, which worked really well because the next week I was taking a week off in Spain to try and kind of recharge. So now I'm back home. Back to looking at Incus and Incus OS. I spent the first few days this week going through all of the open pull requests, reviewing a bunch of things, doing a bunch of tweaks to like Incus deploy. We're looking at adding lint store support, so we've merged that into Incus deploy, fixed a bunch more things here and there. Some other minor features and bug fixes and refactorings, all the usual stuff. And now kind of back to looking at Incus OS today. So I figured I'd take you for the ride and go look at where we stand and what's happening there. So Incus OS, what happened recently? So I don't remember exactly where I was at in the last live stream. I think I was working on putting a bunch of the logic in place to handle GitHub interactions and like for the first boot story. And that's mostly kind of where it was before. So here on January 16th, kind of before going over to Europe. There were a bunch of bumpiness around make OSI breaking, so I had to work with the upstream, who conveniently was also in Brussels, so managed to sort that out and get it back up and running. So, and maybe just do a demo of where we stand right now with this stuff. So as usual, I'm gonna need kind of 2 releases and just show what the first boot experience looks like with the new logic that actually needs to be turned into a daemon, and then we can take a few steps forward on there. So let's start with this release and go into a terminal here. So I've got the Incus OS code base open. Let me just check what changes I've got. Nothing. Okay. So usually that's where I do a few more small tweaks in the scripts, specifically spawn image. We don't need to do any of the extension stuff. That can all go away. And we don't need to download those extensions. That can go away too. So we just download the OS effectively here. Okay, so that's it for the spawn image, and we won't use the rest, so that's fine. It's just one script I need to change. Now, spawn image, all it does is it takes the version we want and the name of the instance we want to run, so let's call it Incus OS, and go. So that's gonna download that older image from January 16th, and we'll just create a Incus virtual machine using it. That just takes a few seconds to actually download the image. I don't remember if that image was already using the new compression settings, but these days I think we're looking at around, was it like 300 megs, something like that for the image? So it's pretty lightweight. So yeah, at this point it's just waiting for the VM to be up and running. The first boot, it injects, it sets up secure boot, so it loads the platform keys and actually gets all of that stuff up and running, so that from that point on, it only trusts what's coming from like directly from Incus OS. So effectively, we have a signing key that's been generated, that's stored as a GitHub secret that can be used by GitHub Actions to sign those images. And on first boot, the key gets loaded into secure boot, and then that key is used to validate the boot sequence of anything after that. So that effectively locks the VM to only booting from updates that were signed by the same key. Now it's up and running. Also on first boot, it will repartition itself, will set up disk encryption using the TPM that's attached to the VM, and just get things up and running that way. So now we've got Incus OS running. So if we go in there, yay, we've got a shell, we've got this thing booted, it's running 6.12.9. And there's like no tool, no nothing, so we can't really poke around, but it also doesn't have Incus or anything on it. Now is when we get another terminal here, and we go and build the, where is it? Incus OS the CMD. Oh, actually, I should go in the folder. There we go. So the Incus OS the command, we build that. Actually, I should make it static just for good measure in this case. I don't think it matters because I'm using the same Debian version in both cases, but anyway, let's make it static. Then we can transfer the Incus OS the binary into the VM. So Incus OS and transfer it into the root folder. So it's here, and then we run that binary. And what it does is it notices that we're out of date. So it starts up in release mode. So that means it's effectively the stable mode. It wants to run Incus. It notices the current release we're running is 01.16.18.27. There's a newer one called 2025 01.31. So that was generated at the end of January. It goes and downloads the update for that and then reboots the system. So that's why we got disconnected here. Then give it a little bit for it to come back. There we go. If you're hearing noise and stuff, it's because I've got snow clearing outside. We're getting 15 centimeters of snow today on top of the existing, I don't know, 20 centimeters that we've had recently. So They're just cleaning all of the driveways so that it's actually possible to drive in and out of the place. All right, so running Incus OSD again now. It's gonna notice that it is up to date, so the same version is running as the one that was found online. That's good. And so it moves on to the next stage, which is the download of the system extensions. So it downloads debug ra, Incus ra in this case, and loads them up, at which point, hey, we've got debugging tools and we do have Incus. So that's cool. That worked pretty well. And we can initialize Incus and then we can, launch whatever you want in it. Let's do, say, Alpine or something like that. There, it's running, we're good. So that's where we stand right now. Obviously, there are a bunch of things that need to be done. One thing is starting to build that process as an actual daemon, not just as a one-time command. That will then need to be added into the image as a systemd unit, making sure it starts on boot, making sure it like outputs clear stuff on the screen so that the user who's booting Incus OS for the first time knows what's going on and why it's gonna be rebooting and the like. That's perfectly fine, we'll do that. The other thing that it needs to do, and something I'd like to look at doing today, is we actually need to build up a bit of persistent state in there. Currently, that command doesn't store anything on disk at all, and it's fine for what it does right now, but only kinda. So if I run it again, you're gonna see something. If I run it there, it's done loading those two system extensions again. And you might be wondering, why is it doing that? Clearly, I didn't push a new update or anything. Well, the problem is that there's effectively no way for it to know what version it's already running. For the OS, not a problem. We've got text files. You can look at user lib OS release, I think. Yeah, there we go. You can get the version from there. It's fine. You can't do that with the system extensions. Systemd sysxt list shows the extensions, but they don't have like really a version file or anything. So we have no idea what we're running. And because we have no idea what we're running, we're just updating them every single time. And that's obviously not really viable. But we do know the version of those extensions on GitHub. So what we need to do is actually record in a file what we have installed. So effectively listing the currently installed extensions, and for each extension, what version we used. And so when we run the tool again, we can now go and figure out like, oh, actually, there is an updated version of the extension, so I can go and update it to a newer version. And if not, it doesn't do anything. So that's basically my goal for now. That should be very straightforward. There's a bunch more things with Incus OS. Since Incus OS daemon needs a bunch of cleanup. I've started to split a bunch of stuff inside internal. So we've got a kernel keyring thing that's pretty clean, a systemd thing that's pretty clean, but we don't currently have the GitHub interactions have not been cleaned up. There's a bunch of more things to do. But this state piece, I figured would be pretty interesting to just get done. It's also something I can easily do within the hour or so I usually keep for those live streams. And since I've already used 15 minutes of the live stream to just describe where we're at, that's also cutting in that time. So basically what I wanted to do is create a new folder. So we'll probably want var lib incus-os. So we need to create that. And then at the simplest, we'll probably do like a state.yaml file or something along those lines. We could do JSON. Yeah, actually, JSON is easier. We don't need external dependencies for that. So we can do a state.json file, which then stores, currently, the only thing we need are the list of applications, so the system extensions and what version they were. And then once we have that, we can make sure to write and read that file as appropriate when the command runs. And if we see the version is the same as we already have, then we don't do anything. So let's try and get that done. That should be pretty easy. For that, let's create a new package. So just trying to avoid piling more stuff up onto the mess that I have in here, where like all of the GitHub stuff and everything is kind of all all mixed in. I mean, it's not that bad, honestly. The GitHub Go API is pretty straightforward to use, so it's not like we have much to abstract away in separate Go package. It's still wrong, so we need to get that done. Anyways, back onto this. So let's create a new package. We'll call it state. And we'll do so kind of that, and then we'll do, I guess, file.go, something like that, call the package state, and then the imports for that stuff. I'm trying to remember, did I do logging directly in the internal packages for the other? No, I did not. So I did only in the command. Okay, that's fine, that makes sense. We can do that. So I don't need to import the logger. We'll just log from the main command itself. And that logging is kind of what we want to see be reported to the user on screen once we do get to that stage. All right, so import, I mostly need encoding JSON then. And we'll do maybe a first function called load. I've actually used contexts everywhere, even when it's not really used yet. Just kind of for being able to easily fit that in the future if anything needs to be cancelable within the file. So another question is, do we just hard code the file location or do we pass it as an argument? The easy approach now might just be to have an internal variable. Just do like a variable in there and then just read from that. So we can do just load, and load would then return a state struct. So calling it state within the state package is always a bit weird. Do I have a better name for it? Because it's not really configuration, it is state. I'm gonna just call it state for now. Maybe I'll come up with something better later. So, and just adds the docstring. So load passes the on disk state file and returns a state struct. Okay. All right. And here we can define a state path, and we'll just define it as varlib IncusOS state.json. Okay. Then we need to actually pass this thing. So we'll do a new, let's call it as to avoid defining state within state. And we'll just make that a new state struct like that, and then JSON dot and Marshall, and we'll want the body, which is going to be the text content of the file, and then pass in where we want to expand it, what we want to pass it into. Okay. Return an error here if something fails. If it doesn't fail, then we return I can return a pointer like that to the state and no errors. Okay, and I mean, I'm gonna be using that as well. Okay, now we need to actually read the content of that file. So let's just do it the easy way. So just do body error, and I think it's in OS these days. They moved it. It used to be like IOUtail or something, but I think we've got to read file in OS these days, so we can do that. State path. And then just return the error for this guy. And that should be it for load. Now we obviously need a save as well. Okay, save writes out the current state struct into its on disk storage. So let's do that and save. So this time it needs the state to be passed in, okay, like that. And we can return an error. We don't need to do that. This moves down here. We don't care how much we wrote as long as we wrote it. Write file, the path, and then the body of that thing. Return the error. I'm going to be returning an error here too. And that JSON thing here goes basically there. And we return null if everything went well. And that JSON, actually this guy like that. JSON this time becomes Marshall. I think Marshall returns directly the array. So we marshal the data we want. And that should be it for this one. So at this point, we've not actually defined what is in that JSON struct at all. So currently that would not build. But we can go and do that with, let's do struct.go, still package state, and now type state struct. State represents the on disk persistent state. Okay. And that's where we want effectively an applications entry. We can make that a map of string to string, I guess. Yeah, we could do something fancier down the line where we turn that into objects. Does it make sense to do structs at this point? So we're gonna want the application. We might want to know where it came from actually down the line. So that might be useful. And we might want to store more stuff like who signed it or something like that maybe. Okay. So instead of, we can do a map going from the name of the application to another struct. So we can do, we can just do it application, I guess, something like that. Map string application, yeah, that should be fine. And then we need to say just had to serialize that into JSON. So the name is going to be applications lowercase this time around. And then we need to define the application struct. Represents an installed application system extension, just to be clear, because it's up, we're going to be calling it an application as far as users are concerned, but within the system, it's actually a systemd system extension. So that way we know what we're talking about. And again, it's a struct. And this time, so we already have it by name, so we don't need to put its name as a property, even though it could be useful eventually. If we start passing this thing around, then we're probably going to want to put a name property that duplicates the value from the map. For now, we don't really need that. So the main thing we need for now is literally just the version. So we can go with just that, but at least we have the struct in place. So if we do need to extend that in the future, it's easy. We're not going to break the on-disk format if we add more fields. So that's kind of the idea there. Okay, so let's just clean that up. Mixed name and unnamed arguments in file. Oh yeah, I think I know what I did. Maybe not actually. Try mixed name and name. Oh right. This one should have its name, so that should be less there. Yay, it's happy. Okay, let's look at whether this thing even builds. It does not. So 35 in file.go is not happy. I think write file requires files permissions actually. So let's do 600. We're running this stuff as root. We don't want users to really be able to read any of our data in general. Not that they'll be able to. Incus OS is so locked down, you won't have a shell anyways. But yeah, let's not tempt fate. And write file, I thought it was returning a length, but maybe not. Okay, cool. All right, so that builds fine now. The other thing that we don't currently do is actually create the path leading to this folder. So state path shows that it's valid IncusOS state.json, but nothing actually creates valid IncusOS at this point. So we'll need to also add that to the loader command. So we can go here. varlib should always exist. So we just need to create the varlib Incus OS folder itself. So what we currently do on startup is we prepare logger, then the current version, that stuff, well, that's the local version, so that's fine. Yeah, and then we go and pass the command, we go and pass the keyring, and then we do the GitHub stuff that needs to move somewhere else. Okay, I mean, first tiny detail is since we are interacting with systemd here, it would probably make sense to do getting local OS information. So we've got to keep track of that. Now here we should create and set up the persistent state. So get persistent state. Let's do that. I'm actually thinking of something, but yeah, we might actually reshuffle the state struct a bit. I'm thinking it actually makes more sense to have the ability to save it be directly on the struct itself. That would make sense. Yeah, let's go do a bit of reshuffling. So if I go in here, instead of save being like past the state that way, what we should actually do is make that a function on the state itself. Okay, so that's just that. And then we've got load, which, yeah, it loads, it gets us a state back, that's fine. As part of the state struct, now we need to store its path, that'd be convenient. So path is a string, and we don't want that field. Actually, we don't even need it exported at all. So just get that as an internal field for now. And that means when we do save, we don't use state path, we actually use, now there's that path. And when we bring up the state, we can already here predefine the internal field. So we can do path and pass in. At that point, since we only use it in one spot, we can literally just hard code it here. But I'm also starting to think it would actually be cleaner to do load. And I'm actually tempted to do a load or create type thing. If no file exists and your empty one is created. Okay, so basically what that does is we set up that state struct thing, we try to do a read file. This might fail now, and if it does, so what we should actually do is and not OS is not exist the error. So if we fail with the file doesn't exist, then we should still use the state just basically as it is. So instead of filling it up and everything here, we should just return it basically. So actually, I think it's going to be slightly cleaner if we just do it this way. So if OS is not exist of error, state file doesn't exist, create it and return it. Okay, so in this case we already have the basic struct up here, so we just need to do save on it with a, so that's why the context we actually need to wire it up, so we pass its context through, and then if this fails, we return that through. If it doesn't fail, then we just return the new state and we're done. Okay, so now load or create can be used. And we should actually, that's what I was saying, we should probably just pass in the path actually here. So the path is directly provided by the user at this point. And we set it there. So we just pass that through. And that should be fine. Okay, let's see. Does that build? It does. Good. Let's just do formatting on it. And now we can go back into the command and get persistent state. So now we can do s error and do state dot load or create, pass in the context and the path that we expect, which is file path, we'll do file path join of, I think I've got some variables already up here. Yeah. So we usually call it var path in our project. So that's Incus OS. And effectively we can do, so what we can do here now is join var path and state.json. Okay. And if that fails, then we fail. And that's still not handling one particular case, which is making sure that we handle the storage directory itself. So what we do for that is we do another of those, and we do os make the of var path. I think, does make that take the permissions? Probably. So let's do it like that. And then if we get an error and the error is not that it already exists, then we return the error. Oops. Let's do that and see if things build. Okay, it's not happy, which is fine. I forgot to import the new package, so just need to do that up here. And declare did not use the state. Okay, fine. So that's fair enough. We're not actually, so we're loading the state here, but we're never actually doing anything with it. One thing we can do now is make sure that we actually save it on exit. So for that, we should be able to just do something like this. S.save context background. And that should be it for saving it. That should actually give us a reference too. Oh, you're right. It must be a function call, right? That. So it should actually give us a reference. So now it's happy to build the file. That's cool. And then what we need to go and do here is when we actually do apply the system extensions down here. Oh, actually, one thing we could. Do we need to do that? Yeah, we might be okay, maybe. I was thinking whether we need to initialize. I think we actually do need to initialize the map to just make our lives a bit easier, so we don't need to like start testing this thing all the time. So state struct file here. Okay, so load or create. So when we do create it like that, we can do applications map string application and actually define that. Just so we have it initialized, and that should work fine with him because it's going to be pre-initialized, otherwise it marshals over it, so we should be fine. Okay. So that's just so we don't need to check whether it's null or not and then initialize the map. It will already be there. which means that going down again to the system extensions here, we're going over the extension, downloading system extension file. When it does that, it does know the release somewhere. Asset ID, get ID, apply system update. Yeah, so it's still this one effectively. The release get name is what we want. So once we've actually processed this thing, let's record this. So record newly installed application. So we're gonna do the state in the applications list, asset I will need to get the actual name for this thing, so I don't think asset get name is quite right. But anyway, let's do that for now. It's a state application thing, and version is that. So let's do something like that. The asset get name, I'm pretty sure is wrong, as I mentioned, because it's gonna be the dot raw thing. Like we can see it here. Dot try.gz. Dot try.gz. Okay, so what we can do here is let's add an extra field. Let's go to application and then call it app name. And for now, let's just do it the easy way, which is we take the asset get name and strings.trim suffix, and we remove the .try.gz part of it. So that should be fine. It gives us an actual application name, which we can then use here. So let's try now. Now that bit just fine. Let's push the new binary over. And currently we don't have a state file. We don't have anything in valid Incus OS. So what I would expect is I run the binary. It's gonna actually create valid Incus OS. It will create an initial state file. It will re-download the applications again because it still doesn't know what version it's dealing with. But this time we're gonna have a record of it in the state file, hopefully. So let's see if that happens. Downloading both applications. Okay, and we're done. Now let's go look at what we got. Incus OS has been created. Let's check the permissions on this guy. 700, we're good. Actually, are we? Yeah, 700. 600, that's good. The state has some data in it. We can see application debug version is that, Incus version is that. Cool. Currently, if we run it again, it's still gonna re-download because there's no logic to skip it if it's if it's currently the same version. But we can go and change that now very easily. So that's convenient. If we go back down here and we just go and check. So check if already up to date. We just need to do the state applications app name dot version. And if that's equals to, what was it, gh release something, this guy. So if that's equals to that, then we don't need to update it. Let's just do it that way. So it's the same version. Skip. Build. Push that over. Run it. Yep, we're good. The one thing that still needs to be cleaned up now is it currently still does those steps. Refreshing system extensions, refreshing users. Actually, no, those bits still make sense. Never mind. Like on startup, we still need those steps to run anyways. Otherwise, Incus doesn't work properly. So let's just reboot that VM to show you what happens then now on the, on the clean boot. I forgot we don't even have the reboot command. We need to do systemctl for that. There we go. So just rebooting the VM, and we should see that it doesn't actually start Incus or the system extensions. It's gonna get kind of messed up, is what we've seen in the past. But now running the command should go and fix that for us. Okay. So, yeah, if I try to access Incus, it's not happy. The daemon is not running. I mean, not sure why this one is complaining, but anyways, effectively we don't have the Incus daemon running. But now Incus OS, it should run. It connects to GitHub, checks the version, everything is happy. No need to download anything, but it just does the refresh of the system extensions, users, and then starts Incus, which means we've got Incus and we're back up and running. So that basically, at this point, the command, again, it's not a daemon yet. That's going to be a pretty easy fix to add to it. But as it stands, that command lets you, like, does the initial update, does follow-up update, downloads the applications, will download newer versions of the applications. So this is effectively ready to be put into the boot process. With just a bit of tidying up, and we're gonna effectively have that flow where you get the right Incus versions automatically, you get the right OS versions automatically, all of that stuff will just work. So we're now at that point where we're also not wasting bandwidth by re-downloading stuff we don't need to download again. So that's all pretty good. In the few minutes we still have, because I'm gonna try and wrap it up in about 15-ish. We can probably go look at static analysis, because that's one thing I was actually kind of doing in the background for this repo, is being very strict on the static analysis stuff. I'm actually trying to remember where I put that stuff now. Oh yeah, there we go, Golang CI, cool. So I made a profile for Golang CI that is, it effectively enables every single CI tool under the sun, minus a few that were giving problematic results. And I was slowly going through that to kind of clean things up. So anyway, what I'm gonna do now is, first of all, commit what we have, and then can go look at the CI, the Golang CI output, and fix a few things there. So first thing we'll do is Incus, how did I name the commits in the past? Incus OS, okay. So we do that. Incus OS, add state package. So we do the state package there. Okay. And then effectively tweaking this guy. Incus OS, make use of persistent state. There. And then the only thing that's left is the script change, which I don't really need, so that's fine. Now, to run Golang CI, I don't actually remember how we usually invoke this thing, because in Incus we have a wrapper around it. So let's go look at the wrapper for it. Where is it? It's in test script or something. Test lint probably. Yeah, no, Golang CI. Cool, so we run that with just Golang CI run. Well, that's easy enough. Let's do that. Golang CI lint run. As I said, like I've set it up to be extremely verbose. So it's got quite a few things it's not happy with right now. Some of which can be fixed, some of which will be fixed later on anyways. So one thing here we can see, for example, the run command is too long. And that's fine. That's not really a problem. Some stuff needs fixing. All right, this is S. Okay, and that's a change. Okay, it's a mix of things. So let's do the one for the state package like that. And then the one for the command like that. And then I can rebase this stuff. So state goes here. And command goes there. So that's fixing those warnings. Let's try it again. Okay. So we can see missing package comments. I don't actually remember how that works now. Is it just a top level comment for the system for the package comments? I think it might be. Let's try to make that happy. So if we go here, usually what we do like a docs.go, I think, package keyring, the keyring package provides useful functions to interact with the kernel keyring. Okay, so if I do that, is it happy for that package? Is that enough, or do we need different syntax? Looks like it's happy with that. Cool. All right, so let's add that. So internal keyring, Incus OSD, add keyring package description. Okay, and I suspect it was complaining about the other two as well. So let's do systemd doc.go package doc package systemd the systemd package offers a number of useful functions to interact with systemd system updates and system with systemd units, system updates, and system extensions. Okay, so that's that. Okay, and then state needs 1, 2. The state package is used to manage persistent data on the disk. Okay, there's a question about like what those comments are used for. That's why I'm not sure about the syntax, because I thought there was something slightly different that you had to do. But in general, if you use like the Godoc website, that will then become kind of top level description for the package, and lets you also put, in some cases, like a basic example for how things are within the package. If we go look at, for example, Godoc Incus, yeah, so if we do the Incus client, which is not the correct URL, actually, this one would be. Okay, so I think that's our top level that I just wrote is kind of where that goes. And then you can write more like of an overview and examples and the kind of stuff at the top level of the package, separately from whatever documentation might be on specific functions. So I think that's what Golang CI kind of wants us to do here, which makes sense. No problem with that. So let's do that and run Golang CI again, see what we've got left to look at for the next few minutes. Yeah, it should have a package comment, so it's still complaining. So we need a different syntax. Let's see if I can figure it out easily from Incus. What did we do? So it was doc.go. Okay, so it goes before the package, right before the package. So that's how that syntax works. Okay, let's try that. So if we do doc and move it like that. So that's the state package. Let's do the other two, systemd doc. There. Oops. I should have done that. Okay. Systemd. Okay, and lastly we have keyring doc.go. Same thing. Let's do the reverse ordering there and see if it's happy. Can rebase that stuff. Actually, I need more history there. So that goes onto state, that goes onto systemd, and that goes onto keyring. Okay. So applying those and see what Golang CI thinks of that now. Here we go. Golang CI. should be of the form package something. Oh, really? Okay, fine. Let's do that again. Fine. That should make it happy. Package state. It's a bit funny having to write it that way, but sure. Fine. Fix them all at once, so now I need to go and commit them all, state, and oops, systemd. Okay, let's rebase things again. So in case it's not obvious, I'm not very good at doing the old Godoc thing. We did it reasonably well, I think, for the Incus client, but we've not really done that for all of our other packages. That's why it's really not a reflex to do this correctly. Is it happier? Yeah, I think those are good now. There's some complaints about functions that should have a comment. That's fair. So we can go and fix those. Because there's a whole bunch of them. It's all within the systemd package, so we can easily fix that. I'll just do all of them and go check. Okay, so I think even the variables it wants it. So system extensions path is the systemd location for system extensions. Okay, system updates path is the systemd location for system updates. Oops. Okay. Fine. Next, refresh extensions. Refresh extensions causes systemd sysxt to rescan and reload the system extensions. Okay, so that start unit instructs systemd to start the provided units. Enable units, same thing. Oops, not instructions, it's instructs. Systemd to enable and optionally start the provided units. Okay, next. Error release not found. Is return, oops, not found. Is returned when the OS release file can't be located. So let's do that. Get release. That one actually does have a correct description. This one does not. So let's do this guy. Apply system updates. Instructs systemd sysupdate to apply any pending update and optionally reboot the system. Okay, so that's, oh, we're getting there. Refresh users. Instructs systemd sys users to rescan, and I think I wrote it this way last time, and reapply user definitions. And we're done. Okay. Did I mess up any of those? Systemd, yeah, it's not happy with the sysupdate one. Okay. Get current release is fine. Apply system updates. Okay. All right, so now it should be happy. Yeah, it looks like it. unhappy about one thing there. Okay, we're good. So, Incus OS add doc strings to systemd functions, and that clears all of that. So now what's left is slightly more interesting. Oh, it shows the main package should also have a package comment. Okay, so that's not very interesting, but sure, we can do this one easily enough. I mean, like the syntax is kind of weird for a main package, honestly. It's used for the Incus OS. Let's do something else. Is it happy with that? Like, you wouldn't think it would be needed for main packages. That makes no sense, but sure. Okay. So yeah, the rest is slightly more interesting because these two are interesting memory usage type things. So we should be able to tweak that a bit to make that go away. So those warnings are actually pretty useful, and we started to do that in some places of Incus, some spots within Incus as well. This one I need to look at, but we can fix the two copy ones because those are interesting. So let's go there. So basically when we do that, io.copy fd body, the body gets copied into the target fd, and it can potentially cause the entirety of the body to be read into memory as it gets slowly flushed into fd. On low memory systems, that's not great. On environments where you don't control the body size or you don't control the speed of flushing into the FD, that can be used to cause a denial of service attack, which is why it's reported here as potential DOS vulnerability via decompression bomb. It's particularly true in the case of compression, like is the case here, because it's a gzip reader. You could have an absolutely tiny file, which is like just emptiness, but potentially terabytes of it. And the reader will extremely quickly expand that to fill up all of our memory when the FD is taking its sweet time to actually write it. So the way you handle that is by doing an infinite loop. And instead of using copy, we use copy n, and then we specify a size in bytes. So if we do that, that would give us a buffer of 1 meg. We can probably go 4 megs to kind of line up with usual sector size and the like. So that should, actually if we do 4 times 1 meg, that's slightly cleaner. So if we do that, then here what we need to do is actually catch io.eof to say that which we'll get once we're done transferring the file. And if we get that, then we can break out of the loop. And that's how we handle those kind of situations. So just see if that builds fine. And if we run the CI tool again, it should be happy this time. Yeah, so that one went away. Now we've got another case of the same thing. So just go look at that one. Exact same fix. We just do a for loop instead. And here we do copy and just change the indent of that block. And then we specify how much we want to transfer, like that. And then in here, if this is EOF, we go and break out of it. And that should make it happy. Actually, it's complaining. Apparently, I broke things. Or comparing with equals will fail, unwrapped errors. Errors is okay, sure, we can do that. In this case, it doesn't matter because we will actually get an IO EOF, but in general, the error is correct. So we should use errors.is. Is that the correct syntax? I kind of hope it is. errors dot is yeah, I think that's the correct syntax. I'm still not very used to that package. Is it happy now? Yeah, it is. Okay. So let's commit that. Actually, yeah, that's fine. Commit, and let's do that. And read from gzip in chunk. In chunks. There we go. Okay. What does n stand for in copy n? It's n as in number of something, so number of bytes in this case. So that just adds the extra argument, which is the number of bytes you want to read per call. And what else do we have? So we can go look at that one on line 113. See what's going on here. Yeah, so it's saying effectively that this is a huge function and that we should probably move that out, which I agree. Not something I'm gonna do right now, but as I mentioned, like the GitHub stuff should kind of go somewhere else, and some of that logic around downloading, decompressing, writing stuff, that should also be abstracted into probably like a utils function or something like that, which will then shrink that function. So that will make it happier. Currently, it's complaining that it's overly complex because that one condition has a lot of logic inside it, which is true. Same thing with this one. It's also gonna get similarly shrunk as soon as things get split into smaller functions, so that's fine. Prefer not to defer inside loop. Yeah, let's see what we can do about that. So it is in 137. Yeah, okay. So when we get that, we get a reader. And yeah, we should. So the problem again is that all of this stuff is not within a function. It should be. And once it will go into a function, then the defer will be better scoped and will actually call pretty quickly. Right now, this is bad. Because if you run, so if this stuff was actually a daemon, which it's not yet, it would start up, it would download OS updates, it would download applications, would download all that stuff. But all of this would be within the run function. So it won't actually return. And since it won't return, none of those defers will ever be called. So we're going to keep like potentially, I don't know, 30, 40 different handles open indefinitely. So that's why it's usually a bad practice to run those in a loop. It's also a bad practice to run them in functions that won't exit, because the whole point of defer is that it's run on function exit. If it never exits, it's kind of pointless. All of this will be fixed by moving that kind of stuff into a more generic download artifact type function for GitHub, effectively, that handles the download and decompress and file creation and all that stuff for us. And once I do that, then that's going to be inside the function. That function won't be long-lived. When that function exits, it will run all of the defers. The issue will go away. Golang CI will be happy. So that's another thing we can't easily fix. And I think I would suspect all three have the same problem. So there's 137, 144, 151, which is probably this one, that one, and this one. So yeah, all three of those will go away as soon as I refactor this stuff into its own function. This one will similarly go away because then that function will shrink significantly, so it will make it happy. And if I'm lucky enough, I'm gonna be able to remove 70 lines of code, which then gets this one to also go away and will be perfectly clean. So I think that's where we are at. Actually, let me move that stuff to my own branch. I just noticed I was in the wrong branch all along. So I'm gonna push that. Okay, interesting. What do I have in my own branch right now? Because it's saying I can't fast forward it. Okay, it's just debugging. Cool, doesn't matter. Can't force push to it then. Okay, And let me just reset this one back to how it should be, like that. Good. And then go here, compare Incus OS, this one. Add persistency and various bug fixes and various lint fixes. Let's do it that way. Okay. And yeah, the way it's currently set up on the Incus OS project, whenever we open a pull request, it actually does the basic checks, so like whether everything has been signed off, which unless I messed up any of my Git calls, it should be. That should clear very quickly. So branch target is good, sign off is good. And then the last one, which is end-to-end testing. This actually takes quite a bit longer because it uses a GitHub Action self-hosted runner. So that's what it shows, it's waiting for it. I can actually show you that quickly. So if I don't have that in my history anymore. Okay, fine. So if I go on my home cluster in the GitHub project, then we can see here, it just started that instance for Incus OS testing. VM agent is not running yet, so I can just wait a bit. There we go. And this is starting up and effectively running Cladinet to install the GitHub test runner inside it, which then connects to GitHub and actually runs the thing. The reason why it's done that way is because I need working nested virtualization, which on the GitHub provided runners is very flaky to non-working, kind of depends on the day. Whereas here we've got 4 AMD CPU cores, like from one of my home servers, directly made available for that. We also have just 4 gigs of RAM. I don't need too much to actually do the testing. And what, 50 gigs of disk or something like that? 100 gigs of disk. And that's all like fast NVMe storage and everything. So that's a bit faster than the GitHub runners, also more resources, and in this case, nested virt, so that the tests can run. So effectively installs Incus, installs make OSI, and then goes through the process of building an initial image, starting Incus OS, loading the extensions, initializing Incus, creating, I think it actually creates a secondary image at that point. Yeah, like it builds a second image and then tries an update. So that takes quite a while as tests go. I think it takes like 10 or 15 minutes, but it validates effectively everything to make sure we're good. It currently doesn't do anything with the Incus OS the command. I need to turn that, as I said earlier, turn it into a daemon, include it inside of the image. And once that's done, then we'll be able to start actively using it. It also currently only interacts with GitHub, which is not useful for those kind of self-built images because those cannot load files from GitHub. They're not the correct signing key. So I need to actually add another source for those updates, which then it will detect on startup that it's in test mode. And if it's in test mode, it doesn't go to GitHub. Instead, it looks at local files that are pushed as part of the test to validate updates and validate the extensions. So there's a bit of more work to do around that inside of Incus OS, but yeah, effectively the logic we have validates at least that the rest of the image is all behaving and nothing regressed. Also actually do need to add another GitHub Actions, which would be a pretty easy one to actually run that Golang CI automatically. I'm just waiting for it to be clean. Once it's clean on my own system, then we can add the test through GitHub Actions so that no more changes from that point on can regress that CI. And that's where I'm gonna leave it for today. It's like, slow progress on Incus OS, but very steady progress. There's actually a very exciting thing I forgot to mention. I didn't mention it, I think, on Twitter earlier today. Starting next week, we're gonna have someone working basically full-time on Incus OS. is from the Future Fusion team, who's also going to be consuming IncusOS obviously for that project. And he's been so far working on Migration Manager, but we recently got a new hire to take over the Migration Manager piece. So Matthias Gibbons, who's also the packager for Incus Incus and LXC and LXCFS in Debian, is working for Future Fusion. Will start working on Incus OS stuff next week. Like his initial focus is going to be on other bits of the Incus OS daemon, specifically the bootstrapping piece. So on first boot, reading a configuration file that tells us how to set up networking, how to set up storage, those kind of things. And on the networking side, it means like interacting with systemd, networkd, having the ability to do bonding and bridges and VLANs and all that kind of stuff. So he's going to be working on that probably starting next week. We'll probably see more activity that way on the Incus OSD codebase, because it won't just be me who makes a tiny bit of progress every week or every other week when I work on one of those live streams, but we'll actually have someone whose job it will be to add a bunch of those pieces and get this project moving faster. So that's basically where we are. There was also a question around, I don't remember what it was, it might have been Mastodon that time around, on when Incus OS will be ready to be used by the general public. And my very tentative answer at this point is maybe around Incus 6.11, so that would make it to late March. But it also depends on what we mean by, usable by general public. There's a good chance we'll have something sooner that will work, but like, do we actually want to trust it with user data? Probably not. And there are a bunch of other pieces we're gonna need to put in place, because if you install this on bare metal today, I mean, first of all, you can't even SSH into it, you can't get a shell, you can't do any of that stuff, so it's not very useful. But even if you could interact with Incus somehow, there are some rough edges around things like the encryption key, which is based on the TPM state. So if you go in your firmware and you change a few settings in your BIOS and you save it, now the TPM state will be different and you won't be able to access your data anymore. Not really a problem in the test environment I'm using, but in production, that's a bit of a big deal. So we'll need to make sure we have a good mechanism for enrolling recovery keys, or providing you with the recovery key as like a QR code or something on startup or something along those lines. So that you don't end up locking yourself out because of all of the fancy security features that we have that can actually backfire and lock you out. So anyway, that's what's coming up next with IncusOS. I'm back home for the foreseeable future now. So other than when I'm doing a Incus release video or also an upcoming video on Migration Manager, in general, the weekly live streams are going to be IncusOS related for a little bit, and I expect to see quite a bit of progress on that by doing it that way. All right, so again, thanks everyone for watching. Hopefully what you saw was useful. It was pretty basic Go stuff this week, like nothing particularly fancy other than maybe just showing where we stand currently with IncusOS. But you might also have learned a bit around Golang CI and how it can be very picky, but also kind of a good thing to keep your Go code base kind of up to current standards and avoid potential issues. All right, so I'll let you all go, and I'll see you in probably next live stream next week. I don't think we've got a release next week. I think the Incus release is the week after. So yeah, should be able to see you all next week. Have a good one. Bye.